Hello. Let's take a look at another three variable right here. So we've got the same things as the last video. Pause if you need a reminder. Alrighty. Let's take a look and see. Now, if you notice that these examples on the notes, each of the examples has one tiny difference. So the last one, the third equation equaled 13. And this is part of the caution about the no solution or even the infinitely many solution is that the absolute tiniest mistake on your part, you multiplied wrong, you subtracted, you did minus a negative and you subtracted, can change the nature of the solution. There's no solution and now you are indicating a point is the solution. Be very careful. Just be very careful like that. All right, so I'm going to proceed exactly like the last example. I'm going to do the elimination method again. I do not like the substitution method, but try it if you want to. So I'm going to multiply the first one by 5 and then by 9 and subtract the second and third equation just like before. There's my equation A. There's my equation B. And I just dive into the next step where I'm going to eliminate y. So there's my 2 by 2 that I just created. I'm going to multiply the first equation by 2 and subtract the second one. And everything cancels out in this example. This is our infinitely many solutions. And we're going to choose z to be our independent variable. Now, I've seen places that let x be independent or y be independent, but we're going to stick with z. I also noticed in the textbook that we're using that it says let z equal the letter t, and I don't understand why, but pay attention to the instructions for WebAssign and the textbook, but I just use z. That's perfectly fine for me. So z is the independent variable, so it's just going to be z. And then I'm going to solve the equation that I've got on the screen, equation A, for y. And now I've got an expression in terms of z, and then I'll repeat that to get x in the same way. So there's my y right there. And so I'm going to plug that back into equation 1. And then I'll solve it for x. So I am at this point doing a type of substitution, so you can't get away from it 100% like that. Plug it in, solve for x, write your solution as a point. Always, if there is a solution, write it as a point like that. Now you can double check this exactly the same way as if these were numbers. A little bit more work, but not too much like that. So you just plug the expression for x, the expression for y, see if it all cancels out to equal the right side, and you're golden. Awesome. My caution from before, pause and read it if you need to.